Hey everyone. So like we said in our first Kickstarter update weeks ago, as soon as we hit our goal, we decided not to do any marketing um, because we sort of wanted to keep the Kickstarter in this happy medium range. There's a minimum number we needed to hit, which was our goal in order to be able to afford to do it, but there's also sort of a maximum number where it's like if the Kickstarter campaign gets too big, it can become unmanageable. You know, we're making promises further into the future, which are harder to keep, and we want to make sure that we're, making promises we can keep. It also just scales everything up. Like, for example, some of the updates and improvements we mentioned in the last update, let's say that adds $30 of cost to each machine. That doesn't seem like very much. But over all of the machines that we're going to be making, that's $41,000. I've never owned a car worth $41,000. I've never owned anything worth $41,000. Um, so basically, we wanted to keep it in this range where we wanted to make sure we have enough, it's big enough that we can make it happen, but it's not so big that it gets out of hand. Our main goal is to deliver to you guys on time. We want to be able to answer every email, respond to every comment, and incorporate your feedback. Like, the whole point of doing a Kickstarter is that like we're all building this thing together. Like this exists because you guys believed in it, and so we want to make sure that we can do that the way we want to do it. So that's why we didn't do any marketing. But now that the Kickstarter campaign is over, we're going to do more videos, more projects. We're just going to be posting more now that we're not trying to be a little bit on the down low. So that's something to look forward to. More videos. We're not going to do a video every week because even like pretty off the cuff videos like this end up taking kind of a remarkable amount of time to film and edit. And also projects also take a good amount of time. And our main project is making this thing. But we will be doing more projects and more videos in the future. A couple design changes and improvements this week. You may have noticed that when it's moving, some of these motors will jiggle a little bit. It doesn't really causing any problems, but we just want it to be better. So we've actually been working on this for a while, but we had to get new motors made, which takes some time. So the motors now have a longer shaft. Will it focus on that? No? Okay. Well, the motors now have a longer shaft, which basically means we can put a bearing at the other end of the shaft and support it, which gets rid of that wobble. Again, not a huge deal, but it's just a better way to do things. And so we're making that change. We also redesigned this clamping piece here. So the old version of this clamp basically had these screws which came through from the bottom, and it pulled down on these pieces. Take this all the way apart. So basically those screws came through from the bottom, and there was, this little wedge piece here, and that clamps down on, there's a wedge in the center there, and that pulls this together, and that's how it clamps. And that worked great, except that it was a little bit hard to access the screws on the top because they're a little bit under the router. The nice thing about this design is it's cheaper to injection mold because it's a two-part mold. We switched it to having a wedge that's this way, and then the screws come in from the end here, which requires a pick out, which is basically a little piece in the mold that gets removed to create those holes. So basically every time you mold one, it comes out of the machine and someone's got to remove that piece, put it back in the mold, and then run it again. So it's a little bit more expensive, but it makes it easier to assemble because you can access these screws from the side and they're not sort of hidden under the head of the router. It's a small change, but we think it's a good quality of life change. We also redesigned these pieces. These verticals were part of this before, and that has the drawback of, because of the way injection molding works, basically these end up being hollow back here, and so the only place that we can put something in between these two parts is in the middle here. And we wanted to move the nut, which runs on the lead screw shaft, for the Z-axis down to this bottom here so we can shorten the shaft for the stepper motors. Basically, we wanted to keep this shaft as short as possible because it's stronger. And so by moving the nut, which runs on this shaft, down like closer to the motor, we're able to keep this shaft shorter. And mostly my concern about these is in shipping. Just with a long shaft, I mean, they'll obviously ship in foam, but I still think that making the shaft shorter will just make it more durable in shipping. The other big thing I want to show off this week is I promised an update on the automatic calibration system before the end of the Kickstarter. Honestly, I haven't worked on it at all since the first update about it. Basically, I made so much progress that first week that it sort of dropped off my list of priorities. I try to sort of like work on the thing that I'm the most worried about and like get that checked off. And so as soon as I got that checked off, it dropped to the bottom of my list. But it's working great. So we're not 100% to our 0.5 millimeter goal, but we're really close, and there's still a lot of improvements to be made to the automatic calibration system. So I'm confident we can get there. To test it, I cut 3 600 millimeter squares across the sheet, and then measured them, and then measured, they were all in a straight line, and so I measured to check that a straight line across the whole sheet is straight. And you can see that they are all within 1 millimeter of where they should be, and I used a laser level to check that the straightness of the cut all the way across, and it's like dead straight. So that 1 millimeter, our goal was plus minus a 0.5 millimeter, we're at plus minus a millimeter. I'm really confident that we can get to the goal. And it's also already like light years ahead of like any of the old systems. This was just run on a 10-foot frame, which is the minimum we recommend, and it was just running the automatic calibration system once. So yeah, it's looking good. Still work to be done. We'll keep you posted when we work on it, but it's kind of dropped off the top of my priorities list because it's pretty good. Since we're trying to do more projects this week, I threw together this bar top arcade cabinet. It's definitely not the thing I've ever made that I'm the most proud of. I designed it in like maybe 45 minutes or an hour. It took an hour and 12 minutes to cut because I ran it at half speed. I was just being a wuss. I should have run it at full speed. And then I spent like 2 hours fixing all the mistakes I made by rushing it. I would like to revisit this in the future. It was sort of inspired by a way cooler one that this guy King of Skolba made in the forums. So I'd like to revisit this in the future at some point when I have time. But I also think it was kind of cool to see like what a CNC makes reasonable as an afternoon project. It was definitely something I wouldn't have taken on without having a CNC. I almost thought about not showing it, but I kind of needed it as a segue to the next thing I want to talk about, which is the Z-axis. So here's how I made it. So generally cutting everything out went really smoothly. I pretty much just ran the file and it was fine. Like I said earlier, I do wish I had cut it faster. This was 1,000 millimeters a minute. I think I could have comfortably done double that. Ignore those other parts. Those are part of a different project. Here's a close-up of cutting the gears. That big hole in the center of the sled, I've actually had some issues with that sucking up small parts when they become detached. So it's really nice for watching the router bit, but we'll probably have a smaller hole there in the sled on the next version. Also note that the holes for the buttons are oval there. Okay, here everything came out really nice and symmetrical. Everything's looking great right up until I realized that I designed my file for 10 millimeter wood before I bought the wood, and then I forgot to update it. So here you can see my slots came out perfectly right on 10 millimeters, but my plywood was actually turned out to be 12 millimeters once I bought it. And then I drilled out those oval holes with the world's dullest spade bit, and here's the final product. So the oval circles for where the buttons are is caused by the forces shifting around as the sled is cutting a small circle. It generally, on like longer straight cuts, seems to fix itself pretty quickly, but those small circles really exacerbate the issue. And it's caused by a couple things. First of all, these sleds are made of SLS nylon, and they're not even remotely flat. I don't know if that's visible on camera, but they're super warped. They're also super flexible. Like, you can really bend them. So they're not very rigid, which means as the forces are shifting, it's flexing basically as it goes around. It's also, these aren't very smooth. They're like a very rough, friction-y texture. And that means that as the sled is going in that circle, it's sort of shifting all of its weight to this outer edge and then flexing. The good news is all of those problems are fixed by the final sled will not be made from SLS nylon. It'll be injection molded polycarbonate. So it'll be a lot more rigid, a lot more flat, and it won't have that flex. But there's also other ways we can improve this. These posts that come up for the Z-axis, where those mount to the sled, I redesigned that to be a bit more rigid. Because this nylon is flexible, it's bending at that bottom place. We'll see how much the switch to polycarbonate fixes that issue, but if it doesn't, we have the option to support the top of that rod as well, and that'll make it quite a bit more rigid. And finally, as a last option, if the rod altogether proves not to be rigid enough, we can use a linear rail like this. Obviously not this heavy duty, this one is way too big, but we could use something like this to give us a nice rigid vertical axis. It's always nice when we can find an issue and then solve it sort of that same week or the next week. Unfortunately, because we need to wait for the final sled to really see how much of a difference the switch to polycarbonate makes over the nylon, we probably won't have a full solution for several weeks. But we will keep you posted with any progress or changes we make, and we'll see you guys in the forums. Have a great week.